Dear students, there is one more question let us deal today, that is various nuclear forces. Various nuclear forces. So, nuclear forces are mainly two types. Nuclear forces are two types. Number one, strong nuclear force. Number two, weak nuclear force. Now, properties of strong nuclear force. First one, they act between the nucleons called protons and neutrons. Right? So, the force is same for neutron-neutron, neutron-proton and proton-proton. Third one, they are short-range forces. Short-range forces. Within the nucleus, they act about 1 Fermi range. So fourth one, the range, if we take less than, if the distance less than 0.5 Fermi, they are repulsive. So actually, they act between the nucleons. These are attractive forces. Okay, these forces are attractive forces. Attractive forces act between the nucleons. So the distance between them is less than 0.5 Fermi. They are repulsive in nature, right? That is why they are short range, and more than 2.5 Fermi, they do not exist. They do not exist. So when they are at this range only, 0.5 to 2.5, then only they will exist. At about 1 Fermi distance, average distance, they exist. And they are not the central forces. They are not the central forces. That is, with increasing neighboring nucleons, force increases. With increasing neighboring nucleons force increases up to 12 nucleons around a nucleon, around one nucleon. They are spin dependent. They are spin dependent. So, if the spin is same direction, strong, more attractive, more stronger. Spin is in opposite direction, less stronger. That is, the orientation of the spin depends. That is tensor forces. If the direction of spin is changing, then the force also changes. So, it is explained on the basis of meson exchange. Why this is happening means they are bound together. They are bound together due to meson. Why mesons usually? Exchange. So one meson comes here, goes there, comes here, goes there. And what we can say, every nucleus, that is every nucleon, like proton or neutron, proton UUD, up and down quarks, it is formed with that, and neutron, one up and two downs, it is formed. So there is a gluon exchange between them. So within the quarks, there is a gluon exchange in the quarks of the nucleons. So these are some important properties of nuclear force. And whereas in the case of weak nuclear force, this is responsible for the radioactive decay. So next one, weak nuclear force is responsible for radioactive decay. Like alpha, beta particles, emission of alpha and beta particles, and nuclear fusion, nuclear fission, etc. Like that, they can be explained based on the weak nuclear force. This is about the short answer question for the various nuclear forces.